Good morning, everyone. Today I'm going to talk about a new chapter. So, chapter 10, arc length and sector area. Alright, so let's go to the next slide. So, over here I have a circle, alright, and this is the center of the circle. Let me label it as my center O here. And what if I am asked to find the length of this? How do you do it? Okay, so I just realized in order to find the length of this is actually called the arc. Alright, so if we are asked to find the arc length of this, okay, which is highlighted yellow, and what we need to do is, so the arc length, okay, so you can actually see the arc length here. Okay, so in terms of the entire circumference of the circle, right, the arc length actually takes 120 degree out of 360 degree. All right, so because one round here is 360 degree. Okay, and for this arc length highlighted in yellow, it takes only 120 degree out of the 360 degree. Therefore, you can see I am actually taking 120 degrees divided by 360 degrees here, right? And then I need to times, okay, since I'm finding the length of this, okay, which is highlighted in yellow, so I have to times the length of the perimeter of the circle, which is 2 pi. Alright, so if you simplify it a little bit, get 1/3 times, so 1/3 times 2 pi r. Okay, and if you simplify it further, you get 2/3 pi r. Alright, so this is your arc length in terms of pi and r. Right, so of course sometimes your angle might not be given in 120 degrees. All right, so your angle can actually be given in radian mode. Right, so let me just so let me get rid of this first. And what if the angle is given in radian mode? Okay, so what if your angle is given as 0.5 here? All right, so over here, okay, over here I'm actually doing this question in degree mode. All right, so because the angle given was 120 degree for here. All right, but now I've changed the question. Okay, I've changed the question and I've changed the angle to 0.5. All right, so 0.5 here, so let's call this my angle. Okay, so this is my angle. Actually equals to 0.5 right now. Alright, so if the angle is given as 0.5, so what the question is asking you to do is you're supposed to do this question in radian mode. Alright, you're supposed to do this question in radian mode. Okay, so how do you find the arc length in this case? Alright, so we are finding the arc length, which is highlighted in yellow here. All right, so similarly, so the concept you make use of here is, okay, so you use the angle which is given as 0.5, okay, and you over the entire angle in radian mode. So what is the entire angle in radian mode? All right, so the entire angle, which is one round here, okay, is actually 2 pi. Okay, so this means 360 degree is actually equal to 2 pi. All right, if you simplify this, you can actually see pi is actually equals to 180 degree. All right, okay, so please remember this. Okay, 360 degrees is actually 2 pi. All right, so if you simplify it, 180 degree is equal to pi. So this is the conversion. Okay, this is the conversion between radian and degree. Okay, when it comes to the value of the angle. Okay, so that's how you convert. All right, so now, so since you have taken 0.5 over 2 pi, so similarly you take the arc length over the entire perimeter of this circle, which is 2 pi r. Okay, so you can actually see, you can simplify this entire thing into, okay, you can actually simplify this entire thing into just, so you cross multiply first, right? You cross multiply, so you have 2 pi, the arc length go to 2 pi r by 5, right? So if you simplify this, you can see you can actually cancel your 2 pi on both sides. So you are simply left with arc length go to r times 0.5. Okay, all right. So r times the angle given in radian mode. All right. So I have demonstrated to you how you can make use of this formula, if you can call it, or this method to solve your arc length in degree mode, and I have demonstrated to you how you can solve your arc length in radian mode. All right, so these are the two concepts, and the conversion between radian and degree is, you can simply pick the simplified version. All right, so pi is equal to 180 degree. Okay, 180 degree is equal to pi. Okay, that's the conversion between radian and degree mode. All right, so now let's take a look at how we can actually find the area. Okay, so how we can actually find the area of this. Okay, this is called a sector. All right, so how can we find the sector area? Okay, so I'm going to do it in degree mode first. So I'm going to do it in so very simple. So you have your 120 degree here. So 120 degree over 360 degree. Why? Because 120 degree over 360 degree, that tells you are taking only this area. All right, and then you want to see what is the fraction of this sector over the entire circle. That's why you take 120 degree over 360 degree and times, how do you find the area of a circle? Pi r squared. All right, so if you simplify this, get this. All right, in terms of pi and r. Okay, so that's how you find the sector area in degree mode. All right, so now let's take a look, how can we find our sector area in radian mode. All right, So instead of this, all right, in fact your 120 degree is so let's do a conversion. By the way, for the previous question over here, I didn't do a conversion for 120. I simply just put 0.5 as the angle in radian mode here. Alright, so please take note. But over here, so let me do a conversion of 120 to radian mode. Alright, so 120 degree is equal to how many pi? Right, let me take it. Alright, so we know that 180 degree is equal to 1 pi, right? So 120 is equal to how many pi? Alright, so 120 is equal to, if you take out your calculator, you can simply just get the equivalent pi for 120 degree. 180 divided by 120, so 1 over this. Okay, the answer is 2 over 3 pi. Okay, so how you can test whether this is correct or not? So you can test this whether this is correct or not, right? So what you can simply do is you put in your pi as 180 degree. So you actually see you get 2 times 60, which is 120 degree. All right, so that shows your this 2/3 pi is correct. All right, so I've just shown you the proof. All right, let me erase it and continue. So since this 120 degree, I convert it into radian mode, which is 2/3 pi. So what I do right now is I'm going to find out the, oh, it's not arc, okay, so it's sector area I'm talking about now. So the sector area, what you do is, oh, by the way, it's in radian mode. So what you do is you take the angle in radian mode over 2 pi is equal to the sector area over the the area of the entire circle, which is pi r squared. Alright, so what you do now is you simply just do a cross multiplication. Okay, you simply do a cross multiplication. Or before that, you can actually do this. You can actually do a cancellation first. So cancel these 2 pi first, and you simply end up with, so this is 1, since you cancel the 2 pi and 2 pi here, so you simply end up with sector area equal to, so 1/3 pi r squared. Alright, so can you see for sector area, get the same answer here? Alright, can you see? Okay, so I have demonstrated to you how you can actually find out your sector area both in V-mode and in radian mode. Okay, so that is the concept for this chapter I want to share with you. Alright, so hope you have enjoyed my videos so far. Thank you for watching my videos, and please subscribe to my channel. Alright, so you get updated regularly. Alright, so thank you for watching. Bye bye.